Well, you went all the way out there, Trent, already. I have another quote here, and that's from Letter from Utopia. It's also pretty all the way out there. Don't worry, we'll get to the technical parts in a second. It's your brain's special faculties: music, humor, spirituality, mathematics, eroticism, art, nurturing, narration, gossip. These are fine spirits to pour into the cup of life. Blessed you are if you have a vintage bottle of any of these. Better yet, a cask. Better yet, a vineyard. Be not afraid to grow your collection. The wine cellars have no ceilings. So that is the kickoff for today's panel. So happy to talk neurotech with Trent, who you already know, and Sandberg, who chaired our whole brain emulation workshop this year and has written the whole brain emulation roadmap a long time ago with Nick Bostrom. Brett from Cortical Labs, who's going to do a fun demo later as well. Brett Love, who we just had on for a really wonderful presentation on Brain GPT. And finally, Robin Hanson, who wrote Age of M, which I'm sure many of you guys know. So maybe let's get right into it. I know we have like a lot of ground to cover, especially after this, lots of discussion topics. But maybe just start us off with like, if you kind of like either take like a historic approach or just see like, what is like a thing in neurotechnology that you're particularly excited about in the next 5 years? Like what is something that we can actually physically achieve before we go all the way out there? And it can be your work. You can speak.
I've answered already.
Yeah,
so
good.
Go ahead.
Okay. Should I start?
Yeah.
So brain emulation is interesting because, are we ready to emulate small brains? And the answer is not yet, but we're getting closer to actually having a serious possibility for that. Certainly we have a compute to simulate small brains. We are having interesting networks, but we're also finding out that it's surprisingly tricky to make that mapping effort go really well. But we're actually now finally starting to make that connection. And that's partially inspired by all the awesome stuff biotech people are just doing. Expansion microscopy sounds like a totally daft idea until somebody does it. And suddenly we can image neurons and other things on a magnificent scale. We're getting tools to find out the neurochemistry and biology of cells that were unthinkable a few years. Ideas of molecular ticker tapes, that's just plain crazy to me. And the biologists say, that's just what biology normally does. This is just pushing it a bit further. And I realized as a computer scientist, thinking about the more dry side of this, I have a lot more to learn here, what the biologists are up to. And they might not even know what tools they could generate to make the computational side easier. So we need a strong connection here to build this research field. And that, I think, is starting to happen.
Hi, everybody. I'm Brett from Cortical Labs. We work in a slightly different area. We look at the question of, can you use neurons but as an engineering source to create an intelligent device of some sort or for some other purposes? And you said you wanted a quick background of the field. Is that correct?
I mean, if you want to venture into the past or go into the future, go for it, but keep it brief. Just to contextualize your work.
Yeah. Okay. Well, I guess I'll start with just like why we decided that this would be interesting. And obviously there's historically people have done work looking at how do neurons work, how do they function, understanding the sort of fundamentals of what makes us us. I think it was captured very well before in the talk we just heard that humans as the intelligence we have is pretty remarkable. I'm not sure about the exact numbers. I know you said 20 petaflops. Whether that's the case or not, to run 20 petaflops on 20 watts of power is an enormous achievement. And even if we can, go further with, let's say, machine learning, AI-based technologies, can we do it with that power efficiency? It seems unlikely. So we can all agree that there are remarkable things about the human brain. So we became interested, well, can we interact with that? And I guess we can dive more into that later. But that's essentially where we started to look at, can we use these neurons not just to copy what humans are, but to extend in an engineering-based approach?
Well, why don't you just say, where do you think it's going to be in 5 years? You're already wrong.
Where will this technology be in 5 years? Sure. Well, to begin with, we think that the important thing is to have lots of milestones. I think one of the challenges with a lot of technologies that people create is that they want to paint the big, pretty picture that's at the end of the road, because that's what gets investors excited to say, look, there's going to be a infinite TAM that you can approach. But the reality is that to get there, you need to have smaller roadmaps. So we think like the near-term immediate applications are very much like research. Billions of dollars gets poured into understanding how do neurons work, how do you achieve with that. The obvious next step from that that's also readily achievable is stuff like drug discovery. If you want to test a drug on, let's say, a mouse, well, a mouse only barely mimics how a human behaves. There's a reason why testing on mice poorly translates to clinical trials. But if you can test on neurons, that's great. But you have to test the function of neurons. And the function of a neuron is not to express a protein or even to have an action potential, a small little electrical burst that happens as they do something that fires or spikes, as people often call it. It's actually to process and do something with information. So if we can interact with neurons in this way, we can actually do, say, drug testing on them. But once you can do drug testing and understand how you modify and modulate with, say, drugs or diseases, the way that neurons function, then you can step forward onto, autonomous systems and eventually maybe even something like generalized intelligence. And again, that's not a crazy idea because we are the ground, as we heard this morning from Fred saying a similar thing, we are the ground truth for whether or not biology can lead to general intelligence, because whether or not machines can lead to general intelligence, there are some great theories. We don't know. It's not been achieved yet, I would argue. We might disagree there. But we are, from bees to snakes to spiders to cats to us, all show a generalized intelligence, and we all use biology for it. So I think it is possible to get there. Sorry if I took up too much time.
No, I'll try to be more. So I mean, no, it was amazing. Scientifically, I'm really excited about being able to do large-scale simulations from percepts to behavior and try to account for activity in multiple brain regions at once, because that just wasn't really possible, even like 10 years ago. And it's, taking advantage of the advances in machine learning and trying to make it a bit more human-like and accounting for behavior and brain response. But that's more like on the science end. But I really appreciate that because I started out with a really brief history. Like basically you just got stuck working with toy models and had limited applicability. You just didn't really know if it was going to cash out in something interesting. There really wasn't this nice dialogue between neuroscience and AI that there is now. But I think practically, there's probably just like Brett mentioned engineering, there's probably all kinds of just refinements of existing technologies that will impact people's lives. Neuralink was mentioned before, but that people, academics have been doing this kind of recordings and demonstrations for years, but now like that technology is sufficiently refined that it could improve people's lives. So that's probably one thing that will be exciting just for the general public. So kind of split it between practical and science. Yeah.
And where do you think RangeGPT?
Oh, yeah. So I should just say, the one reason I would get interested in modeling in the first place is a way to compress the scientific literature, because it's just unwieldy. If you take all the animal learning studies, and if you just know some simple model, say even Rescola Wagner, then all of a sudden you could use that as a massive compression of the scientific literature. But I kind of realized that doesn't even work because the literature is growing so amazingly exponentially fast, and it's really an interdisciplinary field, so you have to keep your eye on so many things that's overwhelming. So yeah, it's just like Allison mentioned, and thanks for inviting me to talk to Foresight about it. We're developing, basically using the same machine learning models to provide a synthesis of the neuroscience literature in a forward-looking way, so you could, scientists could use it to basically put in their methods and anticipate the results and help be more efficient in how they go about designing experiments and testing their hypotheses. But yeah, so I think that's the future. Just sort of first stage will be human-machine teaming. I don't know, maybe those future stages will just be machine-machine teaming, but for now, human-machine teaming. Yeah.
There's a tension between being a long-term and a short-term futurist that we don't often acknowledge here, which is there's a temptation to focus on each month's press release and how exciting they are, et cetera. But that's somewhat not the thing you need to do if you're trying to think in the long term and figure out long-term trajectory. So I've specialized on that second thing. I'm not so up on later short-term things. So I don't really have a thing in the next 5 years I'm looking forward to, but I am looking forward to thinking about when neuroscience will matter more for the larger world. Honestly, it has mattered less so far, but it has huge potential. And so let's talk about when might that potential be released and how.
Well, what do you think? When might that potentially be released and how?
So the usual thing people talk about is brain diseases or something. And obviously neuroscience helps with brain diseases and various medical things, but that's not what's exciting us here, right? Obviously a bigger potential is brain-computer interfaces. And then to an economist, the biggest potential of that is how we bundle tasks. So brain-computer interfaces basically just allows a faster bandwidth between two kinds of things that do tasks. And the way we organize tasks in the world depends a lot on the bandwidth between the things that do tasks. So it doesn't really save humans from being outcompeted by machines in the long run. If you're hoping for that, it just doesn't work. But in the shorter term, it allows us to rebundle things. And so some things that humans do well and machines do well, they can put those together in a bundle. And that's interesting.
Could you venture out what that would be?
No, I don't know. I want to hear what people think, actually, because I struggle to imagine exactly what that would be and why that matters.
Yeah, sure. I mean, just really quick follow-up. I mean, I think your concept of bandwidth is really critical because, I mean, we're already kind of coupled with machines with our phones, and like we've had thousands of years to optimize language for efficient information transmission. I mean, our visual systems could process so much information, so it's kind of hard because you'd have to have something to really compete with that to move it from the peripheral inside. And so, like, yeah, I mean, that's going to be an incredible technological challenge to make something like you're saying that would create a sizable advantage over just playing with our phones and whatnot. Yeah.
So when I was working on enhancement ethics, one of the kind of main things I realized in that particular project in the notice was anything that improves communication in any way between people is kind of a really big deal. Even just a better way of understanding each other matters a lot. Robin has remarked that teleworking might actually be a near-term economic revolution that we're still not actually understanding very well. When or if that happens, we just set up a bandwidth globally with fewer geographical restrictions, which already has big effect. The question is, can you do communication between brains better than language? And language has a ridiculous number of advantages because we're kind of well versed in it. So probably those interfaces need to add something new. And most of the standard things people are talking about doesn't seem to cut it. So we actually don't know what that might be. I've been looking at brain interfaces for AI alignment a bit. And there it might be interesting if something could have access to my evaluative functions and check, do Anders approve of this? And why does Anders approve of this? Once you can figure out that one out, you can start copying some of my evaluative functions, and maybe that's useful for AI alignment. It's still debated, but there is an interesting thing because you're getting something important there, a value, rather than information about official beliefs and probabilities. So we might want to look for what other things do we want to move between brains and tasks.
So I'm fully in agreement with the other statements here. Overall, doubling down on the bandwidth thing, that really is the thing that's holding us back from BCI going to scale, going mainstream. I think two things, actually, the bandwidth, as well as the focus so far for BCI to fix broken humans as opposed to optimizing healthy humans. And that's why I'm quite excited about the latter, where if you can figure out some BCI technology that is aiming for the consumer mainstream, then you go for optimizing healthy humans. And then the question is, what do you do there? And there's this great challenge of a lot of the things you can't do, like it's not going to be better than if you have a smartphone, right? So where is the killer app there, right? And no one knows for sure, but there are many hypotheses, right? Maybe it's pragmatic telepathy to text to someone if you need to be in situations where you need to be silent. Maybe it's silently controlling the devices in your room, turning on and off the light switch. Maybe it's helping with dating. Who knows, right? So these are the interesting questions. And then in terms of the bits you're sending back and forth, one way is where the AIs interpret your signals, send the information across to another person or to the computer in ways that are sort of easy to understand, like text or otherwise. But there's also this opportunity for brain-brain communication directly, right? So imagine a future where you've got pretty good optogenetic sensing of your brain signals, and it creates a 2D movie of it over time. And I'm wearing some optogenetic device that senses this, and Robin is wearing some goggles, and he's seeing my brain patterns in real time. And over time, our brains are very plastic, so we can learn to see other people's brains directly, and it'll do pattern recognition. This is something we haven't really pushed on at all. I don't know of any real research on it, but I would love to see what happens. It's similar to like the telegraph operators of the world. They would think in Morse code. They could actually type and their telegraph in Morse code, which is just foreign to us unless you practice. And so practicing here on direct brain signals could be a big unlock as well. There's going to be steps towards, but I would love to see these experiments more. Maybe you know some.
You first. I was just going to touch on the challenges with BCI, and I think one of the things is this assumption many people have that, you put in and you have the flow of information and we'll just figure that out. But if you look at something like, let's say, the Neuralink monkey, because I think some people saw the Neuralink monkey playing the game Pong, and when you get down to the way that that's done, it's not as exciting as it might initially seem. It's not reading the thoughts. What the monkey does is it uses its hand and it plays the game, and there's motor cortex up here and it activates in a certain way, and then they train their BCI to read the motor cortex activity, and then they simply take the paddle away from the monkey. Well, the monkey's still using its its motor cortex, it's still activating to play the game, and it works, and that's really cool. That's really interesting, but it's not sufficient to communicate complex language. You may be able to do some simple image-based visual things, and that's about the cutting edge of what we could not only achieve now, but potentially ever achieve with the framework we have. So what we need to innovate with is not just the bandwidth input-output, which is an important aspect for sure, but we also have to start to understand fundamentally, like thoughts, intelligence, all the stuff that's hard to put a word on that makes us us, that you want to communicate. Like, how does that underpin it at the most fundamental characteristics of what we are? Because that's what you have to communicate. Even if you have the bandwidth, we need to understand how to frame that and that.
Oh yeah, just really quick follow. I mean, just your comment about like we need a new way to communicate. It was just prompted me to think like maybe what you're saying too about getting at the deeper thoughts, just not the sensory motor periphery, which is where a lot of the brain-machine interface happens. If you could just do things like look at how your representational states change, and if they're aligned with someone you're having a conversation with, like basically just kind of the similarity structure, like when you transition in the conversation and event, are you drawing the same boundaries as the person you're speaking with? You can get like maybe some like real-time information about how synced up you are with somebody. So that would be something that like maybe a new way of communicating. Like you just have like a little meter when you're talking with someone, like how synchronized are we in this conversation or not? And I guess you don't have to be if you're having an argument or something, but it would still be useful information. So that I could see that would be exciting. Yeah.
Oh, go ahead.
Anders reminded me of what I should have said in answer to your question earlier. Now I can say a really big thing that should be happening and that matters a lot. So think of industries in the world on one extreme as, say, automobile manufacture, and on the other extreme as plumbing. Automobile manufacture acquires global scale economies where you can specialize the task into an enormous number of tiny tasks and have each person do that task and really learn it well. And so if you made cars like you do plumbing, they would be vastly more expensive. That's how you first made cars. Each little team just makes a whole car, and that's just crazy expensive. But we have all these other industries like plumbing where they have to be done locally, and so we don't achieve global scale economies. But if you could have plumbing done with a local avatar and swap in people at the other end of the avatar to do each little part of the plumbing task, then plumbing could become as specialized as automobile manufacture. Now we're talking many orders of magnitude productivity gains in all the tasks that we can take away from being local special tasks done by a generalist who has to be local and therefore do lots of little general tasks, to tasks being done by huge international teams of people who specialize, who then come to do your plumbing or gardening or whatever it is, but they are broken into thousands of people who each do a little part of it. Then we can achieve enormous scale economies. That's trillions of dollars of value on the table.
I love it. Plumbing is the new killer app. Wonderful. If we take one thing away from this. Yeah, do a final comment, then we move on.
I want to briefly respond to the idea that from Brett maybe we need to understand how thoughts work, et cetera, before we can get really far. And I want to stir up some controversy, make this panel exciting a bit.
Do it.
So overall, I think we don't need to. I think it's a worthy thing, but this has actually been a long-time thing in AI. People would say, we need to understand symbolic AI before we make the next breakthroughs. And what keeps happening is that just more compute and more data keeps pushing the boundary, right? So, and it's basically the silicon Midas touch, right? As Ray Kurzweil has talked about. So, a good example is DNA sequencing, right? As soon as DNA sequencing touched silicon, it hit this much steeper exponential curve, right? And we had rapid advances, 10x improvement every year or two, et cetera. And I think that's going to be like, we have a bit of the silicon Midas touch already in BCI because we're using AI, et cetera. But side by side with the silicon Midas touch, we need the market Midas touch. And the market Midas touch is what I was talking about with going from iPhone 1 to 15, right? Where you start small, but then the market demands more and more and more and pushes it and gives it money in order to go from the iPhone 1 to the iPhone 2 and the iPhone 2 to the iPhone 3. So the iPhone 1 equivalent of BCI is non-invasive stuff where it's just the motor control stuff, just moving your eyes, all that. But then the market's going to want going to number 2, number 3, number 4. And at some point along, if there's enough benefit to really figuring out what thoughts are in all of this, then the market will pay for it, and that will work. And if not, then no. That's kind of how I see it. So the market Midas touch and the silicon Midas touch will take us a long way. Maybe it's not the be-all, end-all, but it can probably take us a long way.
Okay, let's add to the controversy, because I think the problem is Midas had this brother Sadim, and everything he touched to turned into something bad. And I think on my most cynical days, there are not many, I think biology is like that, because biology is slow, it's messy, it's complex, and that is what slows things down. Silicon speeds up your iteration ability. Markets are good by multiplying. You have a lot of agents trying different things. In biology, you need to make an implant and you need to wait until the tissue doesn't get too riled up. And then you need to wait a bit before adaptation steps in and, oh no, the immune system needs to be dealt with. It's slow. And that means that it's hard to do the rapid iteration that really worked so well in genomics. And I'm worried that Neurotech has this fundamental problem that Sadim is kind of up there touching a lot of stuff with his messy, wet, slimy hands and slowing things down while Midas is trying to turn it into gold.
All right. Yeah. So as a
Just don't touch me, man.
yeah, as a cell biologist, I'll try not to take it personally. Look, I think there's a lot of different angles we could look at with this, but I will phrase one. The argument here is that a exponentially growing capitalist-based approach to forever scaling, forever more compute, forever more power is a viable way to achieve a goal. And in a closed system, the idea of exponential growth is thermodynamically and fundamentally unsustainable. If we could achieve it, it might come at the cost of the planet we live on. If you look at the power consumption, let's say for large language models, which are people's current champion of choice for AGI, rightly or wrongly, I don't know whether you agree or disagree, but it is one thing that is certain, thermodynamically with the current models, it is not sustainable for everyone to have their own LLM. I think we can all agree that that's the case. Okay, unless we crack cold fusion or something, which we might. But so I think what I would say is that I think biology, maybe there is some slower iteration going, but the complexity, the efficiency, both in terms of samples, the amount of data that needs to be fed in, and the power far exceeds anything else that exists in the world. And even if it takes us slower, maybe there's value in, as a society, moving a bit slower, but in a way that's sustainable.
Yeah, I mean, I like your like iPhone 1, 2 to 15 idea, but I guess at every step along the way, there has to be some benefit to the user. And you mentioned before the need for a killer app. So kind of going back to what I was saying before, you still have to be able to beat language, as a communications medium. So I kind of think that's like you mentioned before too, like that right now most of the BCI stuff is with like broken people, like someone that's missing a limb and trying to help them out. And maybe that's like just kind of in keeping with what I'm saying, because there's a real benefit. But yeah, I think it's kind of like you said, like what's the killer application? Like why do we need the iPhone? Like why should we upgrade our iPhone basically? Yeah.
Okay, well, I would love to perhaps start us off just with a brief hint towards tomorrow, what will mostly be discussed. If you think about, I mean, you all do pretty different work, right? Like each in the like broad neurotech field. And I would just love to kind of like have an individual point of like, what is kind of the number one thing that, is holding progress back, like of your work, if you think a little bit more like broadly, because I think then we can feed that into tomorrow's realpolitik discussions. Like if there was one kind of like societal thing, coordination thing, funding thing, whatever it may be, pinpointing it here, could be useful. Like, what do you, if you're not working on a specific neurotech application, then also what do you think generally is holding the field back?
Let me call Cryonics neurotech, which it is, and then say it's a technology has been available for a long time, and its major obstacle has been marketing, people feeling it's icky, and that may well be an obstacle to other neurotech. So I raise the issue of what's the marketing problem holding back Cryonics, and might it affect other neurotech applications?
Yeah, I mean, it feels like, at least from my perspective, so many barriers have been removed in the last 10 years with increasing compute and advances in machine learning. There's complaints earlier, and it's true about open data, but more and more people are sharing open data, and there's studies now where people get together just to collect data sets to share. So yeah, I'm just going to use the one everyone piles on is funding, and it just doesn't work for these kind of projects, at least that I have in mind at the kind of scale and speed you want to do it, like the academic model. At least it's not working for me the last few years. So that's what's holding things back from my perspective.
I guess we'll just go along. So the biggest barriers, I think, are the way that we do think about it. I agree with you that there has been a marketing problem with a number of areas. And like when we published our initial work, for those who aren't familiar, we got some neurons too. Badly, but statistically significantly better than chance, play a game of Pong, just as an initial prototype. And a lot of people's reactions were, what's this man-made horror beyond my comprehension? Not the majority, it was positive, but there certainly was a large enough contingent of people with that. And I think it's about reshaping the idea that biology is messy or gross or yucky, because I think that's a very limited viewpoint. I think that biology is beautiful. If you've looked at a real biological neural network and compare it to say an artificial one, the complexity, the connections they form, it's a beautiful thing. And I think if we can harness the power of biology, I mean, you look out the window there and you see this biological landscape that's working together and interconnected, like that's the world I want to live in. The idea of these silicon machines that somehow dominate everything and consume all the power that we have is a concern. So I think if we can change the marketing from the idea of it being gross and yicky to yicky, the yicky's not a word, icky, and to the idea of, to the idea of like, we can use the substrates that make us amazing as an engineering platform to achieve things that we could never achieve otherwise, at least not, sustainably. I think that's the way we solve it going forward. And maybe it'll even help with the idea of merging the biology with the silicon, because it's no longer some alien thing.
So I completely agree with the wonderfulness of biology, but I still point out that that darn Sadim guy is standing around saying, yeah, but your iteration loop in the lab is going to be slow. The cell biology people, oh yes, their cells are dividing every hour. Your neurons, they grow rather slower. And that's single neurons. In many cases, when you have a learning system, it needs to grow up. And if it's a mouse, then it's a question of months. If it's a human, oh dear, now you have to wait decades. So we have that time scale, and that creates a slow feedback loop. It doesn't help that we have a lot of bureaucracy surrounding this and that people find it icky. But I think that slow iteration actually is a real problem. And if we can find ways of short-circuiting that, whether that is smaller experiments that you can do quickly outside bureaucracy, and many people in the neurohacking community are very keen on the transcranial stimulation, and you can iterate on that much more easily. That seems to have potential to get somewhere. But in the end, I think we also lack a kind of statistical or computational tool. We actually are very good at handling data that's clean, well organized, done in a careful way. We're very bad at handling data coming from a lot of places, which is not so clean, not so good, from systems that are not always perfectly comparable, in fact, quite incomparable to each other. We probably would benefit a lot in a lot of this if we could develop tools for that, because then we could start using people doing live recording. We could start using the different things we have in the literature to bring it together. But also asking for a scientific breakthrough of that magnitude is kind of, that's hard to put on the schedule. So it's easier to work on, can we iterate faster?
So just to refresh the macro question of Allison, in neurotech or in your work, what are the sort of meta macro questions that's really holding things back? And I think that the great challenge is it's easy to predict the medium far future, and we can see the value proposition there. But it's very hard to connect the dots from the now to that medium long-term future, right? So the value proposition, we could explore and reshape the cosmos if we are patterns of intelligence on silicon or post-silicon substrate. Great. But how do we get there? What are the steps, right? Or even in my own work with Ocean Protocol, we have created a lot of really great tools for sharing data in a decentralized fashion and so on. But how do we get traction such that this open data economy really takes off and grows and makes money? So in both cases, basically extrapolation is like that final point is hard. And in general, extrapolation to get there might be hard, but if you actually know the final point, the good news is you can interpolate, and interpolation is a lot easier than extrapolation. But there's many paths to get there. In the case of the Explore the Cosmos, my favorite path is the BCI stuff. There's maybe the upload stuff too, if we get better scanning there. Maybe there's some other ideas yet. In the challenge for Ocean, we've internally, the way we approached it is, the core team said, what's sort of a killer app that we can go for now that could really drive things to drive the broader vision of ocean. And even for the BCI stuff, we said BCI is a path, but even a subset. What's that killer app for BCI in the near term, right? And we were talking about that. So to me, there's obvious things that have great value in the medium to far future, 5 years or 30 years from now. But how do you connect the dots to the now with a killer app? And I think one of the best tools we have, it's not a full answer, but it's a really powerful tool, is technology trees. I've iterated on it a bit, and I'm thrilled that Foresight is really doubling down on it, Allison and her team. That's really wonderful. So I think that can make a big difference. And to see that really getting crowdsourced more and having super fine-grained technology trees, even for teams. Imagine if each of you, with your own team, you put your roadmap as a team for the next 1 year into this crowdsourced technology tree, the Wikipedia for tech trees. And then you would see, you can have LLMs to teach you about the commonalities and so on. So I think tech trees can make a difference. It's not the full solution, but just recognizing that if you try going for this thing very far away, you'll fail if you do it immediately. So recognizing that the steps in between, and then try to fill in those gaps and getting funded with market forces.
Cool. Do we have an audience question or two? Okay, Matthias, and then we go back.
Do we get a microphone?
No, it's we have feedback.
Or you can shout.
Just shout it out.
All right. So I just have a sci-fi question inspired by the original presentation. So it seems to me that whenever people paint these sci-fi visions of brain-computer interfaces, there is always this sort of image of like there is a future. You have a brain implant in your brain, and lights go off whenever you want to, right? Now, it seems to me that there is a lot more stuff that's kind of happening in human brains apart from that, including subconscious things or unconscious things. Some people would argue that's a feature, not a bug. So it seems to me there ought to be a lot more interesting things in that future than just lights going off without clicking a switch. So I was just kind of wondering if you guys have any ideas in that sort of spirit.
Here is a totally trivial thing that would be actually a low-hanging fruit. Imagine that my computer recognized when it did something I didn't want and quickly corrected itself. For example, today you're getting mouse overs more and more where it's suggesting the completions and quite often the entire pieces of code. Great when it is what you want. Quite often I'm struggling to write something and it's just coming up with a noise of completions. And I recognize that I'm annoyed, but I'm not annoyed enough to try to go into the preference and try to change something. If my computer just realizes, okay, that annoyed Anders, let's do less of that, and adapt it, that would be very useful. This is a totally trivial thing. You probably don't need a BCI for that. You probably can do a galvanic skin response. I think there is a lot on our emotional side. I think the real killer app in Neurotech is going to be able to go into a preference menu on an app on your phone and set your hypothalamic weight set point. I need to lower mine a bunch of kilos. There are other set points in my hypothalamus that I definitely want to handle. Some should be in the advanced settings, and some we should probably agree on. Yep, let's not hack those ones because they're actually causing danger. But I think many of these low-level stuff, rather than sending full messages, is the important stuff.
Yeah, I mean, you could think of so many things that aren't even sci-fi. Again, this is just off the top of my head, but I use a search engine today. Why not? You could have that search engine kind of customized, decoding your brain state and informing what it shows. You could learn, when you're in this state, you want this kind of information. You want this, and I don't know, or anything like Netflix could be that way. This is what he probably wants to watch, given this. So it just seems like that's just generic machine learning, taking in context, and the context just happens to be your internal brain state, and you don't really have to completely understand how those inner workings work. You just get the big vector and hope there's some kind of similarity space the model could pull out that's useful. Yeah.
So I think that's a great question, and I think I view it as more opportunities beyond just using the brain to control stuff, right? And I think ultimately, if you put it into this market-based framework that funds the rounds of research with the over market iterations, then you will have startups that explore the whole space to figure out where the payoff is, right? Just like there's the startup focusing on focus, right? And a good example is there's research out of Carnegie Mellon circa 2012, Mary Lou Jepsen and co, where they're using near-infrared scanning to scan the visual cortex, and they had a database of 100 movie clips, and your visual cortex is actually roughly a 2D grid, and it could take the scanning of that and use that to identify which movie you're thinking from these 100 clips and it was about 80% accuracy. So that's taking an example, that's taking advantage of your brain physiology in a very particular way to use your visual cortex itself as input, right? So that's, an example, but there's so many more. There's probably 500 possible opportunities.
Okay. AI. So one that we have on Manifold, thank you. One that we have on Manifold is, let me connect so that you guys can see what I see. Well, I'm just going to tell you what we have. Neurotechnology is most well known for AI safety with respect to ... And one is BCIs extracting human knowledge, BCIs creating a reward signal, neurotech enhancing humans, understanding human value formation, cyborgism, or whole brain animation. And that came from a previous workshop that Sumner and a few others had done before mine. So I'd love to know, and you don't have to answer that question directly, but like, where do you see an interesting intersection between AI and neurotech? It can either be neurotech for AI safety, or it can be AI for actually advancing neurotech in the area that you're working on. And I know that, you're all working really at the intersection of all of those.
I'll say the obvious thing. If AI developed and changed slowly, then we would just slowly adapt to it and intervene as things went wrong. So the biggest fear is that AI would change faster than we can react. But obviously, if we had whole brain emulations that we could run 1 million times human speed, then we could just have it react and manage rather than try to anticipate. Honestly, the vast majority of regulation that works well in the world is regulation that was inspired by something going wrong and reacting to it. Our history of anticipating problems we haven't seen and fixing them by anticipating is not good. I want the reaction approach if we can get it.
What do you think? Brain GPT go?
Right. Oh, in terms of AI safety, or no, just
in general, it is a fusion between AI and core neuroscience.
Yeah.
So you do it the other way around a little bit.
Oh,
yeah. AI to make more progress on neuroscience.
Yeah. I mean, it's funny, like the whole brain GPT thing, like I focus on neuroscience because that's what I know about, but it's completely actually like generic knowledge intensive endeavor. But yeah, I mean, I like your idea of like a loop too, like use like sort of a brain GPT thing to advance the field that ends up advancing the machine learning through this neuro AI cycle. So like, yeah, I like what you're suggesting, kind of a new virtuous cycle to propel things forward. Sure, why not? Sounds good.
And also for other fields, I guess.
Yeah, no, exactly. Like, yeah. So I mean, I just think we're focusing about this, but I think all the fields have the same challenge of just being overwhelmed with information, needing to synthesize it. And there's just no way that like people are going to be doing in the near future experiments without like machine assistance like this. And so I'm very cognizant of that. Like we're trying to roll out like basically a template to be used by others and try to keep it general and extract some lessons. So yeah, hopefully that'll feed back in like you're saying.
Every other future has that.
Yeah. So I think if I could ask everyone to take a moment and to think, and to try and think what it would be like if you were this super intelligent AI and what you would go after. And I can immediately tell you that you've failed because you can't, because we are incapable fundamentally to think beyond our own perspective. Even though most humans, I hope, have some level of empathy to think of another human, we can barely understand what it would be like to be, we can't, in fact, understand what it's like to be a mouse. We very much cannot understand what it's like to be an AI. And most of the framework around when people think about AI safety, in terms of some of the extent of super AI like we've heard today, it's assuming at some level that AI has human-like traits, and maybe it will, in the way that biblically, man was created in the image of his creator. Maybe we will create AI like that, or maybe it'll be something very, very different. So I think where I see sort of, especially the work like I engage in, is that if we can build up and start to understand the fundamentals of what lead to things like sentience, consciousness, intelligence in the human, perhaps we can build an AI that actually has in the more desirable human-like traits and reduce the risk of it going rogue or make it more predictive, more controllable. Maybe not. But I think that if we can, again, start to understand how we, as, again, the only, the most advanced generalized intelligence on the planet, operate at that bottom-up approach, which is really the only way you can do it, perhaps that could have long-term flow-on effects in terms of AI safety.
I already mentioned trying to learn value signals from brains. I think we can also try to borrow some algorithmic aspects of brains for AI, which might or might not be a good idea. Like, how do you maintain representations when they're based on other representations that are changing? And getting online learning systems to remain stable is a big mystery. How does it happen that we don't all get PTSD or addiction? These are trivial questions that nobody really seems to be working that well on. And I think they're quite important for making safe and useful AI, as well as keeping us healthy.
100 years from now, and maybe 20 years from now, there's going to be thousands, millions, maybe billions of patterns of intelligence living on silicon or some post-silicon substrate. For sure, some of them will be fully AI-derived. And I hope to God some of them are going to be human-derived as well as fun mixtures. So along the way, to your question of what's the most intersection of AI and neurotech, some of the near-term steps are going to be cyborgism, and to generalize, extropianism, to use an older term that I still love. So that's where I see us, and I think that's by far the biggest impact, because with that, we can not only explore the cosmos, we can reshape the cosmos.
Now I want to have just one word from you that other people can afterwards, after the next panel, find you in the speaker room for when we do the break. Say a word of something that you'd be interested to talk about. It can be your project, it can be a different topic entirely, but if people want to find you in the speaker meeting after the next panel, what would you like to chat about?
Sovereign intelligences.
Autonomy.
Icky.
Brain GPT.
Economics.
Wonderful. We have it all. Thank you so much. This was great.